We're going to be going over exercise 37, which is another word problem in the ending of our 4.3 exercises. And I like to do the word problems with you because I know the word problems can be kind of challenging at first because maybe you haven't been taught to think through them just yet. So I don't want you to just take the answer from this. I want you to listen through it because you're not going to be able to do these if you haven't been taught before. And so that's why I'm trying to teach you now is to how would you tackle this next time you see it? What kind of information do we need to pull from this, and how are we going to use it to determine our answer? So exercise 37 reads, it is currently 0 degrees outside. The temperature is dropping 2.5 every hour. Identify an inequality that represents the number of hours that must pass for the temperature to drop below negative 20 degrees Celsius. So I need to, I can kind of sketch this out, and in my mind I can kind of see that I'm at 0 degrees Celsius, and then it's dropping some point every hour by 2.5 degrees Celsius, and I'm trying to figure out how many hours need to pass to get to negative 20 degrees Celsius. So I need to identify an inequality also, which means I'm going to be using one of my comparison symbols. And then I also see that all of these include x in their options. So that means that x is going to have to equal something. What does x represent? Well, x represents the number of hours that must pass. So I'm going to label x as hours. So x is my representation of time. And so the amount, and then every hour, I also know that every hour it's dropping 2.5 degrees every hour. So that means in 1 hour, it's dropped 2.5. So 1 hour, 2.5. 2 hours, it's now dropped 5 degrees. 3 hours is going to be 7.5. And so what I'm doing basically to determine how much it has dropped is I'm taking the rate, so 2.5 every hour, I'm taking this rate of 2.5 degrees Celsius per hour and multiplying it by the hours that have dropped. And because I'm doing a multiplication operation, I can use that same kind of information that I got from that. And because I don't know how many hours are actually passing by, that's what I'm trying to figure out, and I have something that represents it, I'm going to need to do 2.5 degrees Celsius per hour multiplied by x. And this tells me how much the temperature has dropped after a certain amount of time. And I'm trying to figure out what does x have to be so that I get to drop below negative 20 degrees. So I'm not going to drop to negative 20 degrees. It's not negative 20 degrees and below, it's just below negative 20 degrees. So then we can tell that because all of these symbols, none of them include an equal sign. And so we don't want the temperature to equal negative 20 degrees, we want it to drop below negative 20 degrees. So that means that whenever I multiply, I know this is a lot, whenever I multiply the rate times the number of hours, that represents something separately than just the time that x represents. That represents my current degrees. And the question wants my current degrees to be less than or below negative 20 degrees Celsius. And if my current degrees needs to be below or less than negative 20 degrees Celsius, they would look something like this. And so I would use that as kind of that reasoning as the way to find what my inequality is going to be. My inequality is going to be 2.5 times x. X represents the number of hours that have passed. And then together they represent the current degrees, just like we got from this table that we put over here. I know it's kind of a little sloppy, but this table, every time we multiplied by the number of hours that had passed, we got our current degrees. At some point it was negative 2.5, at another it was negative 5, negative 7.5 after 3 hours. And so as long as we can continue plugging in values for x and get a new current degree. And that current degree has to be less than negative 20. So then my answer would be the first one. But let me talk about some of the symbols in there also. Because the rate is dropping, we also have to make this a negative 2.5 because it's dropping below. So even if it was a positive 2.5, that means the temperature would be going up every hour. But because it's dropping every hour, we want to make that a negative. And so it's going to be a negative 2.5 times x has to be less than negative 20. And then you can actually solve out this inequality. You're going to solve what x has to be in order for, or what values of x are possible in order for the temperature to be below negative 20. And so I'll let you do the solution part of that one. And I know that was a lot definitely to go through for just that one problem. I kind of extended it out a lot more because I wanted to really hit every point. But if I was just looking at this and kind of wanted to do this a little faster, I would say, well, the temperature is dropping. So that's going to be a negative 2.5 degrees Celsius per hour. And x represents the number of hours that I have. So if I multiply by the number of hours, that gets me my current degrees, which has to drop below negative 20. So that has to be less than negative 20 degrees Celsius. So you guys will get to a point where you look at this problem and you solve it out just like that, no problem at all, because you recognize that if it's dropping, it has to be a negative rate. And then x represents the number of hours. And it has to be below 20. It's not going to be less than or equal to 20. It's just going to be less than 20. And then I'm going to let you do the solution on your own. Okay, exercise 38. Exercise 38 says you are moving some of your belongings into a storage facility. Identify an inequality that represents the number x of boxes that you can stack vertically in the storage unit. So, and then the information that I have is a picture. I see that one box is 27 inches, and then the height of the storage unit is 12.5 feet. And just seeing right there that one is in feet and the other is in inches tells me that I need to do something. I need to turn them both into either feet or both into inches. And the easier thing to do is probably going to be to turn them both into inches, because 27 inches as feet is about 2 1/4 feet. And that's just going to be a little too odd to do with 12.5 feet. So it's really a lot easier to just turn that 12.5 feet into inches. And then what you're going to do is you're going to figure out how many times can I stack 27 inches, or a box, on top of itself before hitting the roof of the unit. So I'm not going to do 27 plus 27 plus 27. Instead, you can divide it. Once you figure out what 12.5 feet is in inches, you can divide that by 27 inches and determine how many times you can go in there. But it wants you first, before you do any sort of solving, it wants you to show us the kind of inequality that you're going to be using in order to determine that. Well, reasoning through this problem, it's pretty obvious that if I stack these boxes, I continue to stack these boxes, every time I stack it, it's going to add 27 inches. And that's why this 27 on all of these is being multiplied by x. X represents the number of boxes. And the number of boxes that I stacked has to either be equal to the height of the storage unit or be less than the height of the storage unit. It obviously can't go over it. And so you need to either equal 150 exactly, or it needs to be less than that. But it can't be anything over 150. So you might not be able to fit exactly a whole number of boxes. You might have to fit maybe, let's say, 10 boxes and then leave a little bit of space in between because another box doesn't fit, which would look like this. So you're stacking the boxes, you're stacking, and then you can stack one more, but then there's that little space right there where you can't stack another box. So we wouldn't say that we can stack 4 1/12 of a box. We would say we can only stack 4 boxes. So use that same kind of reasoning to solve out through these problems, because once you determine the inequality, it wants you to solve out the inequality. And then it also asks, what is the height of 6 boxes stacked vertically? So you will be able to figure that out on yourself. And then the last question is, how many boxes can you actually stack inside of this?